Let's see. What do you know about congruent shapes or similar shapes? I know that all similar shapes are congruent, but not all congruent shapes are similar. Confused? Not to worry. In this video, we are going to be looking at the similar shapes and congruent shapes. We'll be looking at what are the characteristics of similar shapes, and we'll be answering some exam style questions on similar shapes. You're welcome to my YouTube channel. Thank you for stopping by. Today we're learning about similar shapes. What are similar shapes? Similar shapes are identical shapes. That is, shapes that look alike, but they're not exactly the same size. You can think of similar shapes as shapes that are enlargements of one another. Whereas your congruent shapes are exactly the same thing. What are the characteristics that define whether a shape is similar or congruent? Let's start with similar shapes. For your similar shape, like I said earlier, the sizes are not exactly the same, but the corresponding angles are the same. Bear that in mind. The corresponding angles are the same. Look at the triangles we have here. We have triangles ABC and triangles XYZ. These shapes are similar because they're identical, but their corresponding angles are equal. Here, angle ABC is same as angle XYZ, the angles in yellow, whereas angle CAB is same as angle ZXY, the angles in green. And finally, angle BCA, the angle in green, is the same as angle XZY. All right, so because of this, we can say that these two shapes are similar. Also, the corresponding sides are related by a common ratio. I have used this word corresponding because you need to be able to match up what side is about the same thing in one shape as the other shape. So the corresponding sides here are related by a common ratio, which we typically call the scale factor. Remember I said your similar shapes could be seen as one shape being an enlargement of the other one. All right. So please note that for similar shapes, we're going to be looking at exam style questions. But sometimes for the exam style questions, you need to be able to distinguish whether you're looking at linear scale factor or area scale factor or volume scale factor. So you need to be able to examine the question critically and know which is which. All right. Now, for the area linear scale factor, we're going to represent it with L. Our area scale factor is going to be L squared. Makes sense, right? If something is just straight, it's just L. If it is area, then it becomes L squared. And like you guessed right, if it is volume, you're going to be cubing the linear scale factor. Not to worry, I know this is a lot of information. By the time we look at some exam style questions, you're going to understand what we're talking about. Okay, let's dive right in. Have you subscribed yet? What are you waiting for? Please do. Let's get into the nitty-gritty of the work. All right, so this is the first question here. We're told that triangle ABC is mathematically similar to triangle DEF. Please, let's read that again. Triangle ABC is mathematically similar to triangle DEF. This means that this question has told us categorically these two triangles are similar. When you have a question like this, you need to identify the corresponding sides. Remember, the corresponding angles are exactly the same, but the corresponding sides are the ones that are related by the scale factor. All right. So here we've been asked to find BC. To be able to find BC, I can see that BC here relates to EF. Okay, it corresponds to EF. But we need to find a pair of corresponding sides that are provided in both triangles to know how to find our linear scale factor. In this particular question, our corresponding sides are AB corresponds to DE. So I know that I could have AB over DE is going to give me the same thing as what? BC over EF. Notice that we've been asked to look for BC. Okay, so it means that what's our AB? AB over DE and BC over EF. They're actually what is going to give us our scale factor. All right, so AB is giving us 51 divided by DE, which is 6, should be the same thing as what? BC, we don't know it, so we could say it's X divided by EF, which is 4. All right, so to find what our X is going to be 51 times 4, the 4 going over there, everything divided by 6. This will give us what our X is. All right, 2 here, 3, 2 here, 2, 3 here, 1, 3 here, 17. So our X, which is our BC, is going to be given by 17 times 2, which is 34 centimeters. So our length BC is going to be 34 centimeters. I hope you understand that. All right, so the next question. Here we have, again, we have two triangles, and the question has already told us that triangle ABC is similar to triangle PQR. All right, and we've been asked to find the value of X. Remember, we need to identify the corresponding sides. In this particular triangle, we can see that side BC corresponds to side QR. Let me take that again. BC corresponds to QR, whereas RP corresponds to CA. Okay, so we can see that we need to use the pair that we know as our first part. And the first one is going to be QR, which is 9.9 over 8.1 will be equal to, if we're starting from the bigger one and going to the smaller one, when you're going to write the second ratio, you need to start from the bigger one and go to the smaller one again. So it means that we need to come back here and say X over 4.5. The linear scale factor is given by 9.9 over 8.1. All right, so finishing this off, this is going to be 9.9 times 4.5 over 8.1 is what is going to give us our X. It's very similar to the first question. All right, so let's do our math properly here. And we're going to have 9 here, 0.9, and 9 here, 1.1, 0.9 here, 1, 0.9 here. I think that's going to be 5. All right, so it means that our X is 1.1 times 5, which gives us 5.5. So our missing side is 5.5 centimeters. All right, let's go to the question. It's still a part of the question we just answered. We're told that the area of triangle PQR is 25 centimeters square, and we're asked to calculate the area of triangle ABC. Because these two shapes are similar, we can use our concept of similar shapes, which gives us a linear scale factor or an area scale factor, to find the area of the other shape. So here we're told that the bigger shape, which is PQR, has an area of 25 centimeters square. So the first step here is to identify your bigger shape. This is our bigger shape here, and this is the smaller one. We've been asked for the area of this one. What you need to do is, since what the unknown is about this one says this is 25 centimeters square, but we don't know the area of this particular one. Since the unknown shape is a smaller one, the way we are going to pitch our linear scale factor is we're going to start from the smaller to the bigger one. I hope you understand what I just said. Okay, so the corresponding sides again are BC and QR. BC, which is 8.1, divided by QR, which is 9.9. All right, this is our scale factor, and 8.1 over 9.9 is going to give us 9 over 11. Remember, 8.1 over 9.9 isn't a fraction. Our fractions are supposed to be whole number over a whole number. 8.1 isn't a whole number. So when you're asked to simplify a fraction, remember to make sure that both your numerator and your denominator are whole numbers. That's an aside. Need more help with fractions? Watch the video. I'm going to put the link right here. Okay, so this is our linear scale factor. Linear scale factor. Remember, we need area scale factor. Area scale factor is given by L squared. That means we need to square this. 9 over 11 all squared. What do we do with this value? We just multiply it by the area of the given shape. So area of ABC will be given by 9 over 11 all square times 25. Easy peasy. You don't need to know any of the other dimensions. So long as the question is said they're similar, we apply this this idea to it. Okay, so if you simplify all of this, your final answer is going to be 7355 and so on. Remember, we're required to give our answers to 3 significant figures when the values are not exact. So this value to 3 significant figures is going to be 16.7 centimeters squared. Let me go over this. When you're given the area of one shape and you're now asked to find the area of the other one, and you know they are similar shapes, because remember this question starts from here. First step is to find the scale factor, the linear scale factor that relates the two shapes, which is what we found here. It's 9 over 11. All right. And our area scale factor is the square of our linear scale factor. That's why we have squared our 9 over 11. To find the area of ABC, we just multiply that area scale factor by the area of the bigger shape given. And that's how we end up with 16.7. Question number 3. Now, the diagram shows two mathematically similar bowls. The larger bowl has a capacity of 7.8 liters. As I'm reading, I like to fill in my information. So this is the larger bowl, and it has a capacity of 7.8 liters and a height of 11.5 centimeters. Okay, the smaller bowl has a capacity of 4 liters. So capacity means it can hold 4 liters, and we're told to calculate the height of the smaller bowl. All right, so to do this effectively, you need to identify, since we're told that they are mathematically similar, it means we need to think about the scale factor that that both of them have. Okay, now the two values we know in this particular question are the capacity of both. Okay, and capacity is a function of the volume. So whatever scale factor we derive from these two corresponding values that we have is going to give us a volume scale factor. Okay, so the volume scale factor is 4 divided by 7.8. We are looking for height. Height is a length, so we need a linear scale factor. Linear scale factor is given by the cube root of the volume scale factor. Why cube root? Remember earlier we said that to go from linear scale to volume scale factor, we need to cube our linear scale factor. Now that we're going in the opposite direction, since we have the volume scale factor, we are going to find the cube root of the volume scale factor to find the linear scale factor. Now, this is our linear scale factor. What do I do with it? I multiply it by the given length in the bigger one. Okay, so the height of the bigger bowl is 11.5, multiplied by our linear scale factor. You might be wondering, why didn't I evaluate the cube root of 4 over 7.8? I could have, but I'll rather evaluate all my values when I get to my final answer. That makes my work neater and it helps me avoid hasty approximation. I think you should employ the approach to it helps to make your work look neater and you avoid hasty approximation. So I punch this into my calculator. I'm going to have 9.20. I think 049 blah blah blah. And since the value is not exact, the Cambridge IGCSE curriculum requires that when your values are not exact, you give your answer correct to 3 significant figures if they're numbers and if they're angles to 1 decimal place. But since this is just a measure, it's going to be to 3 significant figures. This value to 3 significant figures is going to be 9.20. I hope you understand it. All right, let's go on to the next question. Questions 5 and 6 are the really juicy ones. Please stick around. Have you subscribed yet? If not, please do. Thank you. So let's move on. Now, question number 4. We have containers again, but the information here is kind of interesting. Stay with me. Now, 2 containers are mathematically similar in shape. The question has told us explicitly that they are mathematically similar. So you need to think about, oh, I'm going to be needing scale factors here to be able to do whatever I need to do. Let's continue. The larger container has a volume of 3,456 centimeters cube. Okay, the volume is 3,456 cm cube. And surface area is 1,024 centimeters square. Whereas the smaller container has a volume of 1,458 cm cube, and we're looking for its own surface area. This is the surface area here. This is the volume. Okay. Personally, when I want to answer questions like this, I believe that making a table, a cute little table of what I know to see what I don't know is going to be helpful. So I'm going to make a little table here to show all the things I know and then identify what I don't know. All right. So here, volume and surface area. These are the details for the large one and for the small one. So volume of the large one is 3,456, while its surface area is 1,024. Whereas for the small one, the volume is 1,458 and the surface area is what I'm looking for. From my table, it's clear that the only value that I have for both shapes is the what? Tell me, what do I have for both shapes? I know the volume of both shapes. So whatever scale factor I get from this is going to be my volume scale factor. Do we understand? Okay, so my volume scale factor will be given as what? Since I'm looking for the surface area of the smaller one, it's better I make my smaller one the term of reference. This is what I mean. It means that the smaller value will be at the top while the bigger value will be at the bottom. All right. So my volume scale factor is going to be 1,458 divided by 3,456. Okay. Now, this is my volume scale factor. But what am I looking for here? I'm looking for my surface area. Surface area is a function of the area of the shape. So I don't need my volume scale factor. I need my area scale factor. But how do I go from volume scale factor to area scale factor? Easy peasy. I first of all go to the linear scale factor and then bump it up to the area scale factor. Let me take that again. I find my linear scale factor, and then from my linear scale factor, I find my area scale factor. What's my linear scale factor going to be? Linear scale factor is going to be the cube root of this. All right? That's my linear scale factor. So what is my area scale factor going to be? Area scale factor, remember your linear scale factor is the first level, your area scale factor is the next level, and to get it you need to square your linear scale factor. So now that we know what our linear scale factor is, we're going to square this value. So area scale factor is going to be given by our linear scale factor, which is the cube root of 1458 over 3456, and we are going to square that. All right, so squaring that is going to give us our area scale factor. Now, what have we been asked to find? The area of the smaller one. So what do? We take the area, surface area of the bigger container, which is 1024, multiplied by this value. If you evaluate this, it's going to be, let me check here, it's going to be 0.5625. So I multiply this by this, and my final answer is going to be 576 centimeters. Pardon me, that would be 576 centimeters. Again, I have not evaluated along here. I came here to evaluate to make my work look neater and tidier. All right, so let's go over this one more time. We have two shapes here, okay, two containers. We are given the details as the larger one has a volume of 3,456 and it has a surface area of 1,024, while the smaller one has a volume of 1,458, and we're looking for its surface area. To find its surface area, it means we need to know what our area scale factor is. Why are we employing that? We've been told that these two shapes are similar. So all we need to do is to find the linear scale factor and then the area scale factor. To find our linear scale factor, we are going to divide the volumes by each other, which will give us our volume scale factor, find its cube root, and then its cube root is the linear scale factor. We square that cube root to give us our area scale factor, and we multiply it by the surface area of the larger container. I hope you have learned quite a lot today. Thank you for staying with me. There's a part 2 video. The part 2 video, we are going to be looking at this question, question 5, where we're talking about the area of two triangles, and then you should find the area of the second one. Also, we have this it seems simple, but you need to pay very close attention to it. And my best one is this question 6. I just love this diagram. Isn't it pretty? I know a lot of students get jittery when they see this. Please don't panic. I promise you we're going to do this together and you're going to get it right. All right? So please stick around and watch out for the part 2 of this video. Thank you for watching. See you in the next one. Bye.